Assalamu alaikum guys, myself Shahid Nazir. In this video we will be discussing about Hexose Mono-Phosphate shunt, HMP shunt. It is also called pentose phosphate pathway or phosphoglyconate pathway. It is alternative pathway to glycolysis and TCA cycle, and it is concerned with biosynthesis of NADPH and pentoses. No ATP is directly utilized or produced during the shunt. Now we will be discussing about the location of this pathway. The enzymes required for the HMP shunt are present in the cytosol of this cell. Tissues such as liver, adipose tissue, adrenal gland, erythrocytes, testes, lactating mammary glands are highly active in HMP shunt. Most of these tissues are involved in biosynthesis of fatty acids and steroids, which are dependent only on the supply of NADPH. Now we will be discussing about the reactions of this pathway.
In the very first step, the glucose 6-phosphate in presence of G6PD is converted to 6-phosphogluconolactone. This reaction is NADP dependent and involves in the synthesis of NADPH. In the next step, 6-phosphogluconolactone is hydrolyzed by the enzyme gluconate hydrolase to 6-phosphogluconate. The 6-phosphogluconate then undergoes decarboxylation to give 5-carbon compound ribulose 5-phosphate in presence of phosphogluconate dehydrogenase enzyme. This reaction also involves the synthesis of NADPH. Now, if we take 6 moles of glucose 6-phosphate, we will get 6 moles of ribulose 5-phosphate. Also, till now, it is called oxidative phase. Now, non-oxidative phase. In presence of epimerase, 2 moles of ribulose 5-phosphate are converted to 2 moles of ribose 5-phosphate. And in presence of ketoisomerase, 4 moles of ribulose 5-phosphate are converted to 4 moles of xylulose 5-phosphate. Now, under the influence of transcatolase, 2-carbon moiety from xylulose 5-phosphate is transferred to ribose 5-phosphate to give 7-carbon cetoheptalose 7-phosphate and 3-carbon glyceraldehyde 3-phosphate. The reaction is TPP and magnesium 2 positive dependent. Here the 2 moles of reactants react to give 2 moles of products that are 2 moles of cetoheptalose 7-phosphate and 2 moles of glyceraldehyde 3-phosphate. Now, transaldolase brings about the transfer of a 3-carbon fragment, active dihydroxyacetone, from cetoheptalose 7-phosphate to glyceraldehyde 3-phosphate to give 4-carbon erythrose 4-phosphate and fructose 6-phosphate. Fructose can be converted to glucose 6-phosphate for further metabolic cycles like glycolysis and citric acid cycle. Now, transketolase acts on xylulose 5-phosphate and transfers a 2-carbon fragment from it to erythrose 4-phosphate to generate glyceraldehyde 3-phosphate and fructose 6-phosphate. Here the rest 2 moles of xylulose 5-phosphate and 2 moles of erythrose 4-phosphate are involved to give 2 moles of fructose 6-phosphate and 2 moles of glyceraldehyde 3-phosphate. Fructose can be converted to glucose 6-phosphate for further metabolic cycles like glycolysis and citric acid cycle, and 2 moles glyceraldehyde 3-phosphate will give 1 mole of fructose 6-phosphate. Fructose can be converted to glucose 6-phosphate for further metabolic cycles like glycolysis and citric acid cycle. Now, if we summarize the reaction, 6 moles of glucose 6-phosphate plus 12 moles of NADP positive plus 6 moles of H2O will give 5 moles of glucose 6-phosphate and 12 moles of NADPH and 12 moles of hydrogen positive and 6 moles of carbon dioxide. In the video, I used 2 voices, my own and an AI cloned voice. Please share your preference in the below comment box for the voice you enjoyed the most, and I'll consider using it in the next video. Drop your thoughts below, and while you're at it, suggest the next exciting topic you'd love to see in my upcoming video. Your input matters. Thanks for spending these 5 minutes with me. Perhaps it is the first video on this channel. If you enjoyed it, share the magic with your college groups on WhatsApp, Telegram, and beyond. Gratitude for being part of this journey. Thank you.